Good morning to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, KR from Bangalore. Today I am going to discuss about third session of Chemical Kinetics, which belongs to third semester BSc, affiliated to Bangalore North University. In this session, I have to discuss mean life period, half life period, and problems of regarding the second order reaction. Now objectives of this session, we have to define mean or average life period of a second order reaction with A is equal to B. Second objective is relationship between half life period and mean life period of a second order reaction, and then solving some problems on second order reaction. Now, after completion of this session, you come to know what is mean by meaning or average of half life period. Mean or average half life period of a second order reaction with A is equal to B. Again, you come to know relationship between half life period and mean life period of a second order reaction, and it is again you have very easy to solve the different problems on second order reaction in half life period of a reaction. Uh, Before discussing this session, you already know about expression of velocity constant of a second order reaction when both concentration of the reactants are same. Again, expression of half life period and velocity constant of a second order reaction when both concentration of the reactants are same. You know about this, and by using these knowledge, you have to study the further for this session. Now, what is mean by mean or average life period of second order reaction with both concentration of the reactant means that is A is equal to B. Now we know that the reciprocal of the rate constant or velocity constant of a second order reaction is called mean or average life period of a second order reaction. Therefore, we know that reciprocal of rate constant of a second order reaction is called mean life period or average life period of a second order reaction. Therefore, T average is equal to, that can be also written as T mean is equal to 1 divided by rate constant of a second order reaction. We know that rate constant of a second order reaction when both concentration of the reactants are same, that is A is equal to B, that is expression is nothing but K is equal to 1 divided by T into X divided by A into A minus X, where X is nothing but degree of dissociation or formation of the product, and A is nothing but initial concentration, and T is time required to completion of that reaction, and K is nothing but rate constant of a second order reaction. Now substitute this value here. You know that 1 divided by, again we know that therefore T average or T mean is equal to 1 divided by K is equal to, it is make reciprocal 1 divided by T into X into A minus X. This can be written as T into A minus X divided by X. This is the relation. Therefore, we say that is this expression, the T average or T mean is equal to TA into A minus X divided by X. Now come to the relationship between half life period and mean life period or average life period of a second order reaction. We know that the expression for relationship between half life period of a velocity constant of a second order reaction is given by T half is equal to 1 divided by K into A. This can be also written as K is equal to, therefore rate constant is equal to 1 divided by A into half life period, that is a T half. That call equation number 1. Also we know that again expression for the relationship between that is a T mean, that is mean life period or average life period, and a rate constant of a velocity. In order to given that, we have already know the T average is equal to T mean is equal to 1 by K. Therefore, from that we can calculate K is equal to 1 divided by T average equal to T mean. This is called equation number 2. And now equating equation 1 and 2. Therefore, left sides are equal. Therefore, there must be a right sides are equal. Therefore, 1 divided by T average is equal to 1 divided by T mean is equal to 1 divided by A into T half. Therefore, we can also be write as making a reciprocal. Therefore, T average is equal to T mean is equal to A into T half. Therefore, this can be also be mean that T average or T mean equal to initial concentration into half-life period, multiplication of half-life period with the initial concentration. This gives that is the mean life period. Therefore, mean life period, thus the mean life or average life period of a second order reaction is the product of initial concentration and half-life period of a second order reaction. Therefore, how do we define that is a mean life period or average life period of a second order reaction is nothing but the product of initial concentration, that is A, and half life period of a second order reaction, that is a T half. And this is the relationship between mean life period and T, that is a half life period of a reaction. Now coming to that is the problems on rate constant, half life period and mean life period we have to solve. The first problem goes to decomposition of gas is of second order when the initial concentration of the gas is 5 into 10 raised to minus 4 mole. It is 40% decomposed in 50 minutes. Calculate the velocity constant. Now this is the problem will be there, and such type of the problems will be asked in the examination. Usually it is appeared in university question paper. Solution for this, given that initial concentration is nothing but 5 into 10 raised to minus 4 mole. Now here X is nothing but X is the fraction of the product will be a form, no, or X will be a degree of dissociation, that 40%. This implies therefore 40 divided by 100 into A. Suppose we are taken that is 100, 40%, 40 will be a completion of the reaction. This means the 40 divided by 100 into A. This can be written as after that is dividing we will get that is 0.4 A. This can be written as A value, we know that this is 5 into 10 raised to minus 4 m. Therefore we can write that is 0.4 into 5 into 10 raised to minus 4. After that is 5 into 4 means that is 2, it is 0.4 means 2 into 10 raised to minus 4 mole. And T also time is taken for this reaction is 50 minutes, and K you have to calculate in this equation. Now we know that A minus X is equal to A minus X we required. Here the equation will be there, that is a rate constant for a second reaction 1 divided by T into X divided by A minus X. This is the reaction, this is the expression in which K is constant. 1 divided by T means that is X divided by A into A minus X will be there, no. Therefore we can substitute this value, that is what is that, which one, A minus X we have to calculate. Therefore A is nothing but 5 into 10 raised to minus 4 mole minus of that is X will be a, that is X will be a 2 into 10 raised to minus 4 we have calculated here mole. This will be get, that is after subtracting we will get that is a 3 into 10 raised to minus 4 mole. For second order reaction, K is equal to, you have to write 1 divided by T into X divided by A minus A into X. Substitute this value 1 divided by 50 minutes. This is the T is nothing but 50 minutes, and A is nothing but 0.4A. I can substitute this value in the form of A only. A remains as it is, and A minus X I have keeping here, that is 3 into 10 raised to minus 4 mole. Therefore this A get cancelled. Then after simplifying we will get that is a 0.4 mean, that is a 1 divided by 50 means it becomes a 0.02, and therefore 0.4 divided by 3 into 10 raised to minus 4 mole per minutes will be there. Then you have to make 0.4 divided by 3 means it will be get that is a 0. What you get, that is a 0.133 into 10 raised to, that is a plus 4 per mole per minute, and after multiplication you will get that is a 0.00266 into 10 raised to 4 per mole per. Just multiply this 10,000 to this, we will get that is a 26.6 per mole per minute is the rate constant of that reaction. This is the how it is calculate that problem. Now next problem is nothing but second problem. The half change time for a second order reaction is 20 minutes when the initial concentration of the reactants is 0.018 mole per dm cube. Calculates the value of rate constant. Here solution for this equation, this problem, given that T half is nothing but 20 minutes given, and initial concentration is given, that is A is equal to 0.018 mole per dm cube, and K you have to calculate. For a second order reaction, K is nothing but 1 divided by the relationship between half life period and rate constant of a second reaction is given, second order reaction is given by K is equal to 1 divided by T half into A. Therefore K is equal to, we can write 1 divided by T half means that is a 20 minutes into 0.018 mole per dm cube. Then you have to make, this is the reciprocal. After calculating we will get that is, therefore K is equal to 2.77 per mole dm cube per minutes. This is the answer for that question. And third more problem, another problem I have to solve here. A second order reaction is 10% decomposed in 30 minutes when the initial concentration of the reactants was 0.1 mole per dm cube each. Calculate the rate constant, half life period and mean life period of a reaction. Now for solution for this question, given that A is equal to, initial concentration A is equal to 0.1 mole per dm cube. Here that is the initial concentration. Then X is nothing but 10% decomposition. That is the decompose, that is the 10%. Means it is a fraction of 10% of A. No, this means 10 divided by 100 into A. Therefore this can be written as 0.1 A. And suppose we are substituting this value, A value, therefore X is equal to 0.1 A also, or this can be converted into value means 0.1 into A value is nothing but again 0.1, that should be a 0.01 mole per dm cube. T is equal to 30 minutes. T is equal to 30 minutes. K is equal to what the question mark. Now also we can calculate now A minus X, because in this equation we will calculate that is A minus X. Therefore A minus X is equal to 0.1 mole per dm cube minus 0.01 mole per dm cube. This is equal to 0.09 mole per dm cube. For a second order reaction, when K is equal to, A is equal to B, that is K is equal to 1 divided by T into X divided by A into A minus X. This is equal to 1 divided by 30 minutes into 0.1 A divided by A into 0.09 mole per dm cube. This A get cancelled. Then after simplification we will get 1 divided by 30 means 0.0333 into 0.1 divided by 0.09 mole per dm cube per minutes. After simplifying, you will get this value, and after multiplication, K is equal to 0.037 per mole dm cube per minutes. This is the K value. Then you have to, by knowing this K value, you have to calculate T half. For a second order reaction, we know also T half is equal to 1 divided by K into A. For that, no, T half is equal to 1 divided by, you have to write K is nothing but 0.037 into mole per dm cube per minutes into initial concentration is 0.1 mole per dm cube. Therefore, the T half is equal to 270.3 minutes. By knowing this value, you have to also calculate that is a mean life period. Mean life period. Now we know that mean life period, average life period or mean life period is equal to initial concentration into half life period. Therefore, you put that is a initial concentration is 0.1 and into mean life half life period of a second order reaction is 270.3. Therefore, after multiplication, we will get that is a 27.03 minutes, and this is the mean life period of this reaction. And these problems I have solved only 3 problems, different problems for practice purpose. You can be practice other problems also. Therefore, so far we studied in this session derivation of an expression for mean life period of a second order reaction and meaning of mean life period or average life period. Second one is relationship between mean life period and half life period of a second order reaction, and also we solved that is some problems on this. So I so far you have understood, okay. Therefore I will ask some questions, you please answer them. The first question will be goes to expression for half life period of nth order of a reaction. The option is nothing but T half is directly proportional to a to the power of n. T half is directly proportional to 1 divided by a to the power of n minus 1. T half is directly proportional to that is a to the power of n minus 1, and D is none of these. I will give that is a 10 seconds for you people. You can choose the correct answer. Answer for this question is B option, because T half is directly proportional to 1 divided by a to the power of n minus 1 for nth order reaction, because we know that T half is T half for second order reaction is nothing but 1 divided by a to the power of 1. Therefore, nth reaction means one digit will be a less. Therefore, T half of a nth order reaction is 1 divided by inversely proportional to a to the power of n minus 1. That is the B option is the correct answer for this question. Then second question, expression for mean life period of a second order reaction. First option, T mean is equal to A into T half. B option is T mean is equal to A into A divided by T half. Then C option is T mean is equal to 1 divided by A into T half, and D option is none of these. I will give that is a 10 second for you people. You have to choose the correct option. Answer for this question is that is A option is the correct option, because the average life period or mean life period is equal to the product of the initial concentration and half life period of a second order reaction. Therefore, T mean is equal to A into T half. This is the right option. And for this I have referred these books for preparation of this session, and thank you.